All right, so we're going to look at how to define shape and how to describe it. It is described in exactly the same 3 sentences. So the descriptions of these should be short and sweet. 3 sentences for each one, same thing. So you're going to see it. But we need to talk about shape and what that means. You do have to be very precise about this. You cannot just fudge it. It has to really be true. Okay? So let's just look at the pieces we're talking about. So here we go. So we're going to be talking about shape, being able to identify and discuss the different ideas of shape. So the first thing we're going to talk about with shape, we're going to look at 2 things in particular. One of these 2 things is going to be true. You're going to discuss one of these about, and you're going to use these to define what you see, okay? Your data can be symmetrical. In other words, that the data is spread out evenly, right? Or you're going to talk about the distribution. If they're not symmetrical, how are they distributed? And there are a few things that are very specific when we talk about describing this shape, all right? So you notice that these boxes can move all over the place. The median can move, the box can be the same, the ends can be the same or shorter, etc. First thing you're going to talk about is the symmetry. If you have symmetry, then what that means is it looks like a mirror image, right? Now, symmetry doesn't mean it has to be exactly, perfectly a mirror image. Now, this one is perfect, right? You see that they're exactly the same number of circles, data points on either side. The median is right in the center of the box, which is right in the center of your data points, right? It's very unlikely that that's going to happen. But that does not mean that your data is not symmetrical. If it looks something like this, then it's still symmetrical. When you're checking it, to choose if data is symmetrical or not, you're going to be comparing 2 things. And those things are the median and the mean. Right? So we're going to learn how to compare those so that you can write a statement to determine if something is symmetrical or not. Okay? So here you go. When you're working with NZ Grapher, this came straight from NZ Grapher, you have the mean and the median in the summary statistics, but you can also check a box when you create your graph that will put a dot on the mean, right? So it just literally says mean dot. Okay, so here in this case, notice that the mean and the median are really close together. If you look at the numbers, they're very, very close together. So that indicates that these things are symmetrical. They do not have to be identical, but they better be darn close, right? 1.69 for both of them, although the mean has more decimal points. So they're very close. That does not mean they have to be identical, though, okay? But pretty much, okay? So you can get your graph. You do not have to do that mean dot, but if it helps you out when you're comparing these things, then go for it. You can always click on it while you're doing your analysis and then take it off when you do the printout. Doesn't make any difference to me. Okay? The value of the mean depends only on 1 point. The number in the what? Middle. The median. So the value, did I say mean? I'm sorry. The value of the median is simply the number in the middle. So it's never going to change for a particular set of data, right? But the mean is determined by all the numbers. So if you have outliers, things that are far to one side, one end or the other, what's going to happen is it can affect your mean. But it's never going to affect the median. So if you look here at what's happening, see those 3 data points are moving back and forth, and it's affecting the mean a lot, but it's not changing the median at all. Okay? So the median is the more stable of the 2. Okay? Now, also when you look at this, notice that as it goes far, let me make it stop for a second. It's driving me crazy a little. All right. Notice that when these data points go far off to the right, the mean also shifts to the right. Yeah, do you notice? And the same thing happens if they had gone to the left, the mean would shift to the left of the median. Okay? That's a very important piece of information. So the value of the mean can move, and it always shifts towards the outliers, towards the extra data. If the data is symmetrical, the mean and median will be equal. Exactly equal? No, but close enough, right? If there's an outlier to the left, this is important, guys. If the outlier is to the left, then the mean will move to the left, and the data is called skewed left. That outlier, the stuff on the left, is pulling the mean toward the left, right? That's why it's skewed left. If the outlier is to the right, it's going to pull the mean to the right, therefore it's called skewed right. Know those terms, because if it is skewed one direction, you must use that correct terminology. All right? Okay. Let's get off this slide before it drives me insane. All right, so look at this one. Let's comment about the symmetry of this graph. First of all, here's the mean. The median right there. Yeah? Now, the red dot indicates the mean. Where do you notice the mean is in comparison to the median?
To the right.
To the right. And if you'll notice, there's a whole bunch more data on the right than there is on the left. Right? So, and that's, on the right than there is on the left. That's what I said. Who knows? It's going to be a fun recording. All right. So that means that it's pulling the mean in that direction. So is this data symmetrical?
No.
No. This is too far off. Okay? It's only one number off, because that would be 10, and that's a little over 11. But it's not close enough to be considered equal. Therefore, this data is not symmetrical. Instead, I would say that this data is what?
Skewed right.
Skewed right. Okay? All right. So just comparing those two gets you the information that you need. So here we go. You can see that the mean is to the right of the median, therefore it's skewed right and not symmetrical. Okay? So you'll talk about symmetry if it is symmetrical, but if it's not, you'll tell me about why it's not. Okay? All right. So, but symmetry is only one thing that you can determine about the shape or spread, the shape of the data. Okay? So if you look at the first one, that one's exactly symmetrical. But if you look at this one, the box plot is perfectly symmetrical, but looking at the data, it's symmetrical, but what do you notice about it? It's split. It's got two high points, doesn't it? Okay? And if you look at the bottom one, that's completely symmetrical, but it has no high points at all, right? It's completely across, and you're going to see what that's called in just a moment. So the second thing you should consider when you're investigating shape is the distribution, or in other words, how the dots are arranged in your data. So not just symmetry alone, but also distribution. So if you look at this one, if you look at the box plot, it's very symmetrical, isn't it? The box and whisker plot. But if you look at your data, is it piled up in the center? No, it's kind of just spread out. But because the box plot is very symmetrical, laid out, what we can say is that these things are spread out in a uniform distribution. They're not exactly the same like those dots we saw earlier, but you can see that they're pretty uniformly spread out. In other words, there's no peak at all, is there? Okay. In this one has one single peak right in the middle on the median. This is what's called a normal distribution. So we've seen a uniform distribution is pretty much just a flat line. And a normal distribution is when you have that symmetrical peak right in the center. Okay? If you look at this one, it has two peaks. And so this one is called a bimodal distribution. Two modes. Mode means number that occurs most frequently. So these peaks give you a mode. Okay? You can have three peaks, but it's very rare. It's not going to happen in your data. We're going to be dealing with mostly data from nature, which is almost always uniformly distributed. Okay. All right. So, data was collected from the random sample. We want to comment on the symmetry and distribution of the following data. If you look at the graph here, the median and the mean, comparing those, the mean is slightly to the right of the median, right? But it's very tiny amounts. So you could justify that this one is uniformly distributed, but it's not, or is symmetrical, I'm sorry, because they're so close together. But you could also argue that if they're not exactly the same, then they're not. What you must do, though, is give me numbers to back it up, whatever you say. Okay? This one is not a normal distribution, because that would mean one peak in the middle. It's not a uniform distribution, because it's not flat all the way across. This one has two peaks, so it's called what? Bimodal. Okay? So let's see how much we agree. Now, see, they call it skewed to the right even with that tiny bit of difference. I wouldn't, but that's fine. They're calling it skewed to the right simply because the mean is further to the right than the what? The median, which means that more data is on the right-hand side than on the left-hand side. Okay? If you gave me the numbers for this, 43 and 44, that's pretty close, right? So you could argue, as long as you had the numbers, that this is pretty symmetrical. Okay? You could say it's almost symmetrical, right? Or slightly skewed to the right. It's bimodally distributed because it has two peaks. And notice they give you the numbers about where those peaks are. If you don't give the numbers about where the peaks are, you're in trouble. Okay? We'll look at some examples here. So we need to talk about symmetry. Does the mean and the median equal? That means we have symmetry. And then we need to see if it's uniform, normally distributed, or bimodal. Okay? So you're going to have some homework where you practice that. Hopefully y'all are doing it. And the big deal for you, though, as well as being able to identify it, is you need to be able to describe it as well. And if you look, it's exactly the same three things we've been doing. Your observation. What is your observation about the shape between the two sample groups? Evidence, numbers to back up your observation. And finally, context. What does that mean in context of your investigation? So let's look at some examples. Here we have two dot plots. Okay. You'll see here the first one, the mean is to the left of the median, which means that it is skewed to the left. There you go. Here in the bottom one, it's also skewed to the left. Yeah? Does this look uniform or bimodal, or what do you think that is? It's got a peak, got a little bit of a peak here, and a peak there, and a peak there, so it's kind of odd. Okay? But skewed left, we'll see what they say about it. Both data sets are skewed to the left, but the year 12 data is more symmetrical than the year 13. Do you agree? That one's more symmetrical. This one has a lot more stuff all over the place. I don't know. That one just bugs me about these 5 dots over there. Okay? All right. But you're going to be working on several of those, and it'll give you a chance to look at what they say, and as long as you support it with numbers, you're in good shape. Okay. Here's some test scores by gender for males and females. Possible shapes section for the report. The female data is more symmetrical than the male data. Do you agree? Yeah. Definitely, because the male data is almost uniform and this one is almost normally distributed. Okay? More symmetrical. And you can also say that because the mean here is close for females is closer than the mean for the males to the medians. Okay? Guys. Then notice they put in the numbers. For females, the mean is shifted 0.45 left of the median. How did they find that number? Just subtract them. Find the difference. Exactly like we did in the other pieces, right? The difference is what you're looking for. So simply subtract them. And for the males, the mean is shifted 1.77. So see that the shift is smaller for the females than it is for the males, which indicates that the females' graph is much more symmetrical than the males. Right? So this means back in the population, make sure you mention the population, we'd expect female test scores to be more symmetrical than the males, and for the males to have more low-scoring outliers than the female. Why did they say low-scoring? because the mean is shifted to the left, and that's where the numbers are lower on the left, right? Okay? So exactly the same kind of ideas, but just talking about a different piece. The female data has approximately normal distribution. First we addressed symmetry. Now we're going to address distribution. There's approximately normal distribution, and the male data is approximately uniformly distributed. Unless it's perfect, you say approximately. Okay? The female data has a single peak centered at whatever, and the male data is fairly spread out. And where do they get that 45 to 80? That's where most of the data is. Okay? And then with some outliers around 40. This means back in the population, we'd expect female test scores to be normally distributed around 76 to 77 because that's where the peak is, right? And the male test scores uniformly distributed between 45 and 80. That's just the range, guys, right? 45 and 80. Notice that there's a gap here and then there's a few over there. So they didn't include those. All right? So very, very similar to what we've been doing. Looks good? All right. Now remember, if I were you, I would have a copy of this somewhere to put in when you're writing your report so that you know the kind of thing that we're going to be looking for.
Is it on
No, it's in Education Perfect, though. That's what I'm saying. I'm not going to put it there, but you can. All right? So put it in OneNote or put it in a Word document, whatever you need to do. The same with those other sample sentences. Get them there. Make sure you label them, which one is being addressed, right? Because it'll give you the weird pieces too. Like, this means back in the population. None of you would ever say that phrase, but you must. Okay?
Back in the population.
Right. You'd never use that phrase, but you have to. I have to be able to see that you know what that means, that it relates back to the population, even though you're doing the sample. Okay? All right. Told you to be short and sweet. Hopefully you're doing these assignments. If you're not, I'm sorry for you.
So
Very, very sad because it's your funeral, right? So I'm going to give you some on shape. And some describing shape. 27 whole minutes. There you go. All right. Now, I'll go get your questionnaire papers. Oh. It's too big of a pain. Do you want the probability or the questionnaire? All right, I just want you to remember this when I ask y'all to do something. Then you know how to do it.
Yeah, but if you're doing, but it doesn't matter.
Yeah, I know, but like that, but like what it is.
A pie, you know, a mince pie. Like, no, I got a pie from Philly Bakery. It was like cold pork and apple. It was 2,000 calories. That stuff is more than you think, but it literally doesn't matter.
No, it doesn't matter. I probably eat like something like 8,000.
We don't even need to talk about it. No need.
Josie, so I just had to see my boss.
I'm gonna get literally 5 on the spot. Because I have to give it like 2 days.
I just had to see him I'm so nervous.
Is that your Asian boss?
Yeah, he's probably gonna get fired.
What if he does
Let me
say
see.
I'll be like, leave. I don't know.
What if he's like?
But it's like 4 to the 8. So
Did
it's
you
like
say
4
it's
days.
rowing? It's not just.
I said spring rowing camp had statistics exam because I said that I can't work those days because they're at 2 p.m.
Yeah.
So then if I'm in for like 3 hours,
It's
then
sort of just maybe a classic chicken box.
Did he ask you to set your
That's
date?
all. That's all.
like he posted on his Facebook.
Yeah.
Okay, guys, listen up. All right, so I'm going to give you the questionnaire paper first. You need to look at it. You need to find wherever it is, find and sign the agreement. If you don't agree, then you need to let me know that too. All right? Joshua. And meet me halfway, guys. Annabelle. Katie.
Yeah. Is this the question?
I can't get them from here. I'm going to stand in the middle and you're going to get the Maddie. Hello, Greg. Gemma. Sophie. Emma. Beatrice. Megan. Brianna. Rio. Lucy.
What is the birthday?
Georgia.
Wait, this is right, yeah.
We can look at it again. Yours was one of the ones that was already, so I can certainly get this.
This one you made it sound like if you wanted the date, it was 28 or 7. Oh man, that's funny. We turned these in on 28 or 7, and now we get them back on 2708.
What now? Okay. Hold on. If you have an issue, do not sign the grade thing, but tell me what Get a piece of paper. If you don't have any paper, I have some up here. Tell me what you think you see and what areas you want me to have looked at again. And I will definitely have them moderated so that we can look. Now, if you can imagine, these things their mistakes are made. So if you think that something's going on, I'm more than happy to look at it, guys, okay? No, I can't do it now, but just write on it and see, and then I'll look at it later. Because you sent them electronically, right? Oh, okay. Oh, yeah. All right, just write it for me, and I'll look at it and see. I'll look at it.
Do you want these?
Because it's on the Turn It In.
Didn't even write this one.
But it's on the version on Turn It In. Is that what you're saying? On Turn It In, the electric version, when you turn it on version, did it show up on there? Can't remember. Look and see. Yes, definitely. I know exactly what you're talking about. I remember y'all annotated on the side. So yeah, let me do that. Let me look at it and see. Okay.
Does the gaps mean like do they do it?
Not necessarily. It means that I showed evidence on it beyond that, so I didn't care.
Oh.
Right?
Wow. I'm really worried now that maybe my boss is going to kill
I made a new chart for them.
Cody, would you mind just shooting me an email to remind me? And then I'll find it and print it and get it to you. Okay? Just email me and tell me that you... Okay? Alrighty. Yes, I must have them back.
Your stapler doesn't have staples in it.
And I don't have any extras here. Sorry. Okay?
Does anyone have a stapler?
All right. If you have questions, please note the questions, and when you give it back to me, tell me that you have questions. All right? Because I want you to get the grade you deserve. Okay. Is this right probability paper? Your probability paper started with tweeting airlines? Yeah, I haven't looked at these at all.
It was so weird.
Now, I'm going to tell you, I have not seen these. I did not mark them. I did not moderate them. So, that means that I know nothing about the grades that you got. All right? Literally nothing. I can also tell you they have that. Thank you. Right? That you must give them back, or they'll be deleted from the system. So be sure to give them back. Okay? All right. We're going to stand in the middle and do the same jump. Meet you halfway kind of thing. All right? Olivia Evans. She's away. Cody. Juliana. Brittany.
Yeah, it was close to my
Oh, God!
That's one question.
That's it.
But I think you got it in one. That's one question.
have a key to this, so I cannot tell you what the answers should look like. But remember, take a look at them now. The greater than or equal to. We did somewhere, right? Where like if you had, when we did distributions, right? And you had two values. So the probability that x is between 40 and 60. Do you remember that?
Yeah.
Yeah.
Oh. Okay.
Right? It just means it's between two numbers, so that, like that. Yeah? And again, I haven't even looked at this, so I don't know if there's anything oddball on there. I didn't hear a lot of complaints about it, so. Guys, here's what the scale is. U is the same as achieved. R is merit. T is excellence. And there are different guys, and there are different scales of excellence and merit as well. Guys, remember, we're now just kind of glad to look at it. Do not stress about, or do not worry about what you did or didn't do, because we have something else to get through, and term 4, we will be really working hard on this. We will take this thing apart and go through every question, right? So that's why I'm not doing it now. It's not important. What's important right now? Inference. Yeah? So don't be stressing about this and don't be worrying about it too much. You will see it again, and we'll go through every single question, and we will review the entire topic again, and we'll do other practices. We'll have a practicing class that we sit just like a real test, and we'll get to prepare you for your external. Okay? Is this your only external? Yeah.
The stats,
Yeah. Look at you guys go.
Yeah, I'm like the cute girls who do 3 in the same amount of time.
But one of them's calculus, that's easy. And the other's probability, the same exact one y'all do.
Yeah, they do this one.
And then
calculus.
algebra. Algebra is crazy. Pardon?
Right, and I was like,
There's some things we look at. I'll put it aside. I'll put it aside.
and this one.
I don't know between the just email me and remind me to look at that. I can stack on this high.
Yeah, and then I figured it out by spelling this.
Pardon? I have no idea. So, but do you have some questions? That you think some things you want? Okay. All right. Again, then what I'd like for you to do is, sorry. See, write out which ones you think need to be looked at. Okay. Guys, again, remember, this can change. So, if you have some questions about the probability paper, the way it was graded, write down which ones you think you need to look at, and then
Click on my name.
I'll have the moderator look at them. Okay?
Click on it, like click on it.
And mistakes do happen, right?
Wait, I didn't know you had to do Fuji and look like this.
Always what?
I don't know. All of my questions are like, give Fuji some
Who in here didn't know you have to do 4 decimal decimal points on probability.
Yeah, mine one said that as well. Mine one said that as well. I did two, but basically every single one.
I have said that like 6 million times.
This-
Probability is always
I got-
taken to what? 4 decimals.
I actually got 4 DP exclamation mark.
Well,
As a comment.
because whoever graded it was
Not you.
disappointed because
I think it's
Who
Miss
did
Brady.
grade
I feel
these?
like this is Miss Brady's.
Wait, no,
Yeah.
it's like this.
No, I feel like I'm
But
just
you
you
write UDP?
No,
I think
she
this
wrote
is-
4 DP with an exclamation mark.
I think Mrs. SM did the original grading, and I don't know if he did the moderation.
Still got that cheap.
But again, if you have a question about something, if you think one of them is wrong and one of them is graded incorrectly, then let me know. You're happy to look at it.
She's gonna jump.
I think it's because you wrote 1 person.
But actually, I'm not even serious. Like,
I wrote a little bit more explaining. I don't know. It's like it's probably pretty like.
Apparently, like, Clingy is really,
Do you want to have a look at it? Is that close? Oh.
Well, how many points I got for you?
Yeah, it doesn't hurt.
Is it 19 or 20?
It's probably 20. I think the ground boundary was 20, but you never know.
Because some of them are like 20, some of them.
Was that a difference between a merit and an excellence that y'all were talking about?
I got.
Yeah, if you got a T on that one,
I got a 2 point there, and that would put you up to.
well, it depends on
That would put you up to an E7 on that question, which would then put her up to 9.
which would still be.
Which, yeah, but it would be. I mean, if this was the actual score, I would say for sure. Wait, how did you get points here? This is just me separately. Yeah, but I'm just
Are you just doing that? Because what was the person you did?
I'm not sure. Again, I didn't grade. I didn't grade or moderate this one. But
submit it to be resolved.
if you have one specific one that you're concerned about, just to make sure. We will look at the whole. We can look at the whole test, but if it's one specific one, that's
I'm so good.
makes it a little easier. And if you can make it easier on the person who's marking it. So, how were they? What you expected? Better? Worse? Not what you thought?
Yeah.
No. How was it as far as your knowledge base, though? Do you think you did you do better or worse than you did the first time? Or the same?
I did better by like 6 points. Enough for the cheat.
Most of them were pretty much, when I was doing the distribution, what you got last time is what you got this time, but then there was some that got some went up, some
I
better.
improved. What
Yeah.
did I get last time? Like a 2.
I either got 3 or 5. I think I got 5 last
But remember, this was the world's worst decision. Let's do probability during the lockdown. That
Oh,
was like
that's
the
so
worst thing we should have done. We should have done inference.
Yeah.
This paper would have been so much easier
I mean, you
to
could
do
have
during the
done
lockdown than this math heavy topic.
But I feel like an internal would also have been easier to some extent. I mean, but with an external, you've got time to re-revise it. So I don't know. Both have.
Yeah, that's true. I mean, you get to see this paper 3 times. Woo-hoo, that's exciting.
I need to go to practice.
Do you original. Oh. All right. If you're done writing your comments. I know exactly. I remember exactly what you're
I believe so.
you got some things you want to email me to remind me because I'm not going to be
They do make sense. I don't know, but they do. Because I was talking to that and he said, yeah, we don't. So we don't need No, they don't. I got my right obviously, guys are impressed.
You guys done with yours?
I know. I tried to talk to you about it.
Alright, do I have them all back? If you wrote down some things that you want looked at, then email me to make sure that I know that I'm supposed to look at them. I'm supposed to look at them because otherwise I'm not going to remember. Because that's the way that works.